what we can tell about an LTI given its impulse response simply. And so we talked about causality, memory, how wide the of the system can be, and so on. And I think someone pointed out that based on HN, we can also say whether the system is BIBO stable or not. Yeah, so of course, with the computation, with uh, by using computation and HN, we can say many more things about the system. And of course, stability is an important um, property of the system. So what exactly is BIBO stability or bounded input, bounded output stability? What does it mean? Someone?
If input is bounded within some range, then output should be also bounded within a particular range to make the system stable.
Output is also bounded within range to make the system stable. Okay. So that is basically if we have a bound B, if our xt or xn, whichever way, xt absolute value of that is less than equal to some b, implies that the absolute value of yt or yn is less than equal to some b prime. Okay. And what is the criteria for that? I mean, um, when is it bounded input, bounded output stable, BIBO stable? When the impulse response is absolutely summable. That is, the impulse response is the sum of the absolute values of the impulse response is less than infinity. Okay, that it is finite. Okay. So now, did you guys do Z transform in signals and systems? Nobody is ready to say anything.
Yes, sir, a little bit.
A little bit. So tell me what was covered in Z transform.
So Z transform, then the properties and this
What properties?
so stability and causality and all those properties.
Um, these properties. Okay. How to get how to represent a discrete time system with difference equations and the corresponding transfer function in Z domain. Was that done? Um, Aniket, Vishwabasu, Charan, Dikshant, Ishita, Harsh Sukheja.
Yes, sir.
So what was done? I mean, were difference equations covered and how to represent it in Z domain?
So difference equation, can you elaborate? Like what?
Like yn equals summation yn minus k ak yn minus k plus summation.
Yes, sir. Yes, sir. This representation was done.
Okay, and so how to represent the transfer function for such a system in Z domain?
I mean, it. Uh,
So that difference equation, everybody, so the difference equation represents some LTI, right? So what is its transfer function? How do you write its transfer function? Like HZ.
So that part was done, but we have to brush
So
up on
some
that.
rational function, I guess.
Some rational function, yeah, it would be some rational function. But if I gave you a difference equation, would you be able to write the HZ of that system? Or what it would on derive properties of the system and so on, and draw the direct structure 1, direct structure 2 of the system with delays and scalar multiples. Were these things covered? It should have been covered. I'm just asking you to make sure. Look, I need your help in this matter so that going forward we are not having to come back to these things.
so these
Sir,
things
we
were
need to
covered, but right now not brushed up. So we need to revise.
So what we will do then is I will cover a little bit of it, but you have to read also. And on Thursday, there will be a tutorial for all these things that in signals and systems you should be knowing about that going forward we will be needing all the time. Is that okay? So why even consider the Z transform? I mean, what is the advantage of using the Z transform? So if you remember, if for an LTI system, um, it's input xt, or in discrete domain or continuous domain, either way, xt yn or yt, and this is an LTI with impulse response hn, or in continuous time ht. Okay, let me see, someone is here. Okay, so what is the advantage of using complex exponentials? Let's say e to the power j omega t, or e to the power j omega n, or z to the power n, where z is any complex number.
So if we use real coefficients, then we won't get coefficients in the left half of the spectrum.
That is the advantage of having these as inputs.
So they are orthonormal basis functions.
Z to the power n also.
No.
So I'm saying that in general, any complex exponential, all these are complex exponential. I mean, this is in continuous time, this is in discrete time. Okay, what is the advantage of using these as inputs? I mean, that is the sort of basis for using Fourier transform or discrete time Fourier transform or discrete Fourier transform for LTIs, I mean for signals that are provided as inputs for LTIs.
They are eigenfunctions for convolution operation.
Yes, they are all eigenfunctions for convolution operations for LTI systems. That is, can you just elaborate on eigenfunctions? That is,
So if the input is this exponential functions, then the output will just be something multiplied with this input itself.
a scalar multiple. It simply scales the input. An LTI simply scales an exponential input to provide the output. And so the Fourier transform or discrete Fourier transform or discrete time Fourier transform, what have you, I mean, they are useful in this context, because if we can represent a signal in components that are complex exponentials, or some scaled, summed, or weighted complex exponentials of different frequencies, that is that omega, then we can easily compute the output, because an LTI follows superposition. And if the input signal is broken down into a number of such complex exponentials, then the output is also created by the same complex exponentials, only scaled. And the scaling is what is the scaling there for e to the power j omega t, e to the power j omega n, or z to the power n?
The transfer function of the system.
It is the transfer function of the system. That is, so everybody knows this, right? E to the power j omega t as input to a system, it produces h j omega into e to the power j omega t as the output. And this h j omega is, how do we define it? It is simply integral of ht e to the power minus j omega t dt. Right? That is the Fourier transform of the impulse response. Similarly, in a discrete time system, if we provide this z to the power n as input, and so this is our xn, our yn is, if this impulse response of this LTI is hn, our yn is basically convolution of these two, that is summation z to the power n, z to the power k, h n minus k, k equals minus infinity to infinity, and that is what? Can someone just say? Would it be easier to write it in some other way? Tarun?
If we write z
R
to the
e to the power j theta.
Huh?
R e to the power j theta.
R e to the power z. No, we don't want to remove the z. We keep it as z. Some other way I meant is,
Z to the power n minus k.
yeah, z to the power n minus k. That would be easier to solve this. Otherwise, you substitute and get the same result. Z to the power n minus k. And this is because convolution is what? Commutative. And so we can get the z to the power n out. And this is summation k equals minus infinity to infinity hk into z to the power minus k. And this is termed as the transfer function here, which is hz and is the z transform of the impulse response hn. Is that okay? Hello. So here again, we are seeing that z to the power n is being scaled by hz to produce the output if the input is z to the power n. This is the standard, I mean, the reason why we go into complex exponentials with respect to LTI systems. Because of this eigenfunction property. And so here, if we now go on to find out properties of hz or properties of the LTI given the hz, what can we find out from given hz? Okay, let us say our hz is simply equals z by z minus a, where a is a, let's say, a real number. What are the things that we need to think about and in making conclusions about the system whose impulse response is Hn? Anybody? See, I would make the class interactive even when I teach new material. This is old material. Here you should be saying, participating more. So please
Sir,
speak up.
if the poles are inside the unit circle, then we say that it's stable.
first thing, whenever we talk about transfer function, I mean, talk about the Z transform of a signal, be it the impulse response or the input signal or output signal, whatever. What is the first thing that we need to say? Because the pole zero structure of transfer function of the Z transform of a signal can be exactly the same, yet the signals can be totally different. Is that true?
So region of stability.
So a region of convergence.
Yes, region of convergence is it is a Z transform is incomplete. Writing this down is incomplete without the corresponding ROC or region of convergence. Okay, so this says that we have a what does it say? So in the Z plane, this is the Z plane. Okay, this is the real axis. This is the imaginary axis of Z. We have a 0 here at 0. Let's say A is a positive number, real number. We have a pole here. Okay. So if we were to derive the corresponding signal, that is the inverse Z transform from this HZ, we can obtain multiple results depending on where the region of convergence is. Okay. So for this case, let us say Z by Z minus A. What do you think can be the region of convergence?
So there are two possibilities.
Why are there two possibilities, Sai, Nishant?
So like if we draw a circle with the radius A, the region of convergence can be inside that circle or completely outside that circle.
Why does it have to be that way? Why can't it be, let's say, like this?
So the region of convergence should not contain any pole also.
Okay. Let us say then region of convergence cannot contain any pole, and that is because otherwise it does not mean that it is converging, of course. So why can't it be, let's say, I mean, can it be this? Then there can be multiple options, not just two options. This or this inside either of these two circles or outside either of these two circles. Outside of either of these two circles is not possible, right? Because of the same reason that we said earlier, that inside of that circle is not possible. And let us say this circle outside of this region and inside these regions. Aren't all these three possible?
So like these can be possible, like they can be the areas where it is converging, but generally the region of convergence is like lies between two poles or between a 0 and a pole, something like that.
No, not
In the
so.
extreme cases.
in the extreme cases.
So like what you said, the smaller circles, in that also the like it is converging, but we consider the extreme cases. So it can be like uh, inside the circle of radius A or outside the circle of radius A.
No, not extreme cases. I'm saying, can the ROC be defined to be this circle? I mean, that if it is here, it is not converging, but if it or outside this is some number, let's say P, that is greater than A.
Sir, I think we should bound Z such that the HZ would be convergent in that region. Like if we expand binomial expansion for the transfer function, then we can find the region of convergence.
Yeah, that is true. What I'm saying here is, in general, can't for a system that has a pole and zero here, we are not talking about just this thing now. We are talking about a system, or rather the Z transform of a signal where the zero is at the origin and a pole at A on the real line. Okay, and we started this discussion with Sai saying that there are only two possibilities of ROC. The one is that the ROC is inside this A, the circle with radius A, excluding A, or it is outside the circle with radius A, again excluding A, up to infinity. What I am saying is it not possible that, why is it that there are only two possibilities? Can't it be a circle with radius P outside of that region, a circle with radius B inside that region, a circle with radius C inside that region, where P is not equal to A, B is not equal to A, C is not equal to A? Then we can have multiple possibilities, not just two possibilities.
Then I think we should choose the maximum coverage area, like which region covers the maximum ROC. Then
Which region covers the maximum ROC? Can you say that that it is that P has to be A? Not why should it have to be the maximum? I mean, why is up to the pole maximum? Why can't the ROC be up to P only, outside of P rather? It's not about maximum or anything. I mean, can you prove that if the ROC is a area outside a circle greater than P in this kind of scenario, then it is true that by contradiction we can prove that if assuming that this is true, then the region in this ring between the pole and P here, that must also be in the ROC. Do you understand my point, Harsh? Yeah, Lakshmi, Sri, Sai.
yes, sir, I got it.
So if the ROC is outside the circle, then it becomes a causal signal. And if it is inside, then it will become an anti-causal signal.
That is left-sided, right-sided. That's
Yes, sir.
okay. That's fine. That is about being inside the circle or outside the circle. But what about the region between the pole and P? See, we are all assuming that what Sai said, that there are only two possibilities. That is inside the pole or outside the pole. The circle inside the pole or outside the pole are the only two possibilities. What I am asking you is, can there be other possibilities? Is the question clear? What we are trying to discuss? First, that.
So like, are you asking if the pole can be within ROC?
Pole cannot be within the ROC. That's why we are ruling out the cases where where a circle that is these circles with radius B or radius C, outside of those regions cannot be in the ROC, or uh, circles with radius greater than this A, inside of that cannot be in ROC. Agreed?
Yes.
Cannot be the ROC rather. Okay. So my question is, what about the opposite? Why can't this be the only region of convergence? Like this radius is P, where P is greater than A. Is that a possibility or not? Is the question clear? Karan, Rocky, Kavya, Madhav?
Sir, can you repeat the question?
Um, so we have this pole zero structure where we have a zero at the origin and a pole at A. Okay, which corresponds to this HZ. Okay. What we were discussing is that this transfer function is not enough. There must be an ROC associated with it. So when we consider this pole zero structure, we are saying that only two ROCs are possible. That is, or at least your friend Sai Nishant was saying that there are only two possibilities. One is when the unit circle is like this, not unit circle, sorry, the circle is like this. Either inside this circle, the red circle is the ROC, or outside the red circle is the ROC. Is that up to here? Is that understood?
Yes, sir.
Okay, so now my question is, why can't this circle meaning the radius P, with radius P greater than A, and not inside the circle with radius P greater than A, be the ROC? The only region of convergence is greater than P, that mod Z is greater than P.
Sir, I think any of them can be ROC as long as there is no pole inside it.
So you are saying that for this Z by Z minus A can have any ROC. So let us say I have HZ given, Chamok Chakraborty, right?
Yes.
Z by Z minus A, and this ROC I'm saying is mod Z is greater than P. Okay?
Okay.
Where P is a real number, A is a real number, and P is greater than A. Is that okay?
Yes, sir.
So what is the signal corresponding to this transform Z by Z minus A ROC mod Z greater than P?
Sir, I have to calculate it.
How will you calculate it?
Sir, I think for the circle, for the region P, for like the P radius circle, it will be converging, but ROC is generally defined for all the points where the entire like thing is converging.
So here is my problem, Shai, is when we say generally defined, we are not really talking about mathematically. Okay. Either it is on this condition or that condition. Do you understand what I mean, Sai? It is no offense to your statement. I'm just saying that that's how we should be approaching things. No. ROC is generally defined is not quite acceptable, don't you think?
Yes, sir.
No
Sir-
offense. I'm just clarifying what you said. That's all.
Sir, you are saying like region of convergence is defined then for P greater than A. So we have to prove that P has to be equal to A, right? Sir,
I'm not saying that.
yeah,
I'm just
you are asking like if it's so I'm saying that we can prove that key P has to be equal to A, just greater than A. I mean, because there has to be a singularity to stop the region of convergence, and when we expand HZ, the first term will be 1 upon Z, 1 upon ZZ inverse, like which will control the boundary. There has to be singularity on the boundary. So P equal to is not.
why does there have to be a singularity in the boundary?
So because I can always push the circle inwards. Because if you are saying that for P it is stable, then I can also show that for P minus it is also stable.
P minus delta it is also stable.
Yeah, yeah.
Uh, how do you prove that?
So I mean, if I just expand HZ, and so the term controlling the singularity, I mean the boundary here is the
So
what.
here, just a second, not to interrupt, just writing out the expanded HZ equal to, it is basically 1 by 1 minus AZ inverse, right?
Yeah.
So that is summation AZ inverse to the power minus 1, right? To the power n, sorry. Right?
Yeah.
N equals 0 to infinity. Is that correct?
Yes.
Okay. So now can you say, so this is converging when mod Z
Greater than A, that greater than P, that is given like
mod Z is greater than P is our given condition. So now we have to show that, okay, this is true, but if we use ZP minus some delta, where delta is less than P minus A, this would still be converging. Right, Harsh? This is what you are saying, right?
yes.
Okay. Yeah. So how do we prove that?
Sir, I mean it's visible only like for P we write it as true, and I mean just we have to just look into this expression. It's the delta won't affect the stability, I mean the convergence condition, unless the delta is less than p minus a, I mean greater than p minus a.
So the simple thing is this is converging for mod z greater than a.
Yes, sir.
Okay, for any mod z greater than a.
Yes, sir.
Okay, so if it is mod z greater than p, it is convergent. For a structure where for the pole zero condition 0 here and pole here, okay, then for p less than a, less than for mod z less than p also, we will get convergence up to
Yes, sir.
a. Okay, so the ROC must be bounded by this pole.
Yes, sir.
So do you remember the properties of ROC?
So properties of ROC. So I remember like if the function is two-sided, then it must be bounded by two poles, and like this kind of stuff are you talking about?
Yeah, always the ROC, the very first thing is ROC is always a ring centered at the origin. Does that ring any bells? Ranveer?
Yes, sir.
So does that ring any bells?
Sir, I have to revise it actually. I don't remember.
Okay. So that's what I was saying, that you guys must revise these things before we go on to DSP. Otherwise, it will be difficult to um, go on to the real stuff of DSP. Okay. Rituraj. Rituraj, why does the ROC always have to be a ring centered at the origin? By the way, those of you who are not realizing, this is also my form of attendance. Arya, Chandan Reddy. Akshat. Akshat is also gone today. Rekha. Divyansh Goyal. Okay, anyone. Why does the ROC need to be a ring?
So
Always.
is it because like we always like when we converge things, we always talk about the mod values?
Yes, exactly. So
So
if it
mod
is,
z implies that it will be a circle.
yeah, if it is true for any particular value of z, then it will be true for all mod z. That mod z. Now, if it is true for a particular z naught, it will be true for all mod z naught. All z that mod z is equal to mod z naught. So it will always be a circle. As the ROC have to be continuous.
So I think yes.
Why?
So because if there is a discontinuity, then like we can't converge like things out there. So there must be some close boundary.
So an ROC cannot be something of this nature inside this circle and outside this.
So I think it cannot be like that. It has to be a ring. So because for one condition, the other like suppose it is a sum of two signals. Sum of two signals. One is causal, one is anti-causal. So there should be a common region of convergence. Only in that part, the whole signal would be converging. Otherwise, one part would be converging, the other part would not. So it cannot happen like that. There can be a ring, like a common region of convergence between the two.
The white part can be ROC, but the
Yes,
complement of a ring cannot be an ROC. Cannot be
Yes,
the
sir.
ROC.
Yes.
But that's still, I mean, I'm not quite completely certain about why that is the case from what you said. Maybe I'm not understanding it, but could you just elaborate a little more? I mean, sure, sum of two signals, one left-sided, one right-sided, then it is a ring because that would be some common region of convergence.
So in this case,
to tell you the basic thing, does a signal always have to be a sum of a right-sided signal and a left-sided signal? I mean, that is the basic assumption for you to say that.
yes, sir, understood.
Can any signal be represented by a left-sided signal and a right-sided signal? Or can be only right-sided or only left-sided?
So I think they can always be represented as the sum, because the signal spans from minus infinity to infinity, so we can break it in two regions up to 0.
Yeah, that is very true, and that is why this is not possible, because this would be meaning that there is no common ROC of the two parts, right?
Yes, sir.
Yeah, exactly what you were saying. I'm just putting more logic onto it. That's all. With your friend's self, not me. Okay, so what are the other properties? So now that we are talking about right-sided and left-sided and both-sided signals, I believe now you are recollecting those things that you had about properties of ROC. Like if it is right-sided, then something. If it is left-sided, then something. If it is both-sided, then something. Divya Sri Tejavat. Guys, I understand online class is painful, but I'm trying to interact with you, and this is material that you should be knowing already. So please try and participate, not just the 4 or 5 people. It's okay to be wrong, no problem. Then I would know what I need to explain further.
If the system is Bebo stable, then unit circle must be inside ROC.
That is a different property. I was more meaning as to the poles and zeros and ROC, and that is one important property that you said, Vishwabasu.
So the finite, like time finite signals and time infinite signals.
Yes, time finite, I mean finite time signals and infinitely long signals. What about their ROCs?
So for finite time signals, it should be whole of the real, like whole of the real plane except some points. That should be the ROC.
Whole of the real plane.
So no, so whole of the complex plane, not real
Okay, whole of the complex plane except some
points, like at
points.
infinite maybe.
Okay, and
So at the pole can be either at 0 or at infinite or both.
And for infinite signals, it must be a
ring.
Do you remember the proofs of this? I mean, it is basically just the logic that we went through in the earlier example that we were talking about. Is the same logic will apply to all of these cases, and we will get the conclusion. So I would suggest that you please relook into your Z transform, the properties of Z transform, some known Z transforms. We will be doing these in the tutorial on Thursday. There you will have to do it yourself, at least first. The TAs will not solve it for you until some of you at least do it. Okay. So I think our time is up, and we made some progress. I was hoping to make much more progress today. We have a double lecture on Wednesday. I hope we can get into the real material by within that double lecture. So I would urge you again to please uh, go over the things that we are talking about in class in the past two lectures, in today's and the last lecture, and please, so that we can more quickly go into the DSP part of the course. We don't want to repeat things for a very long period of time. Okay. Okay, thank you. So if there are no questions, you are free to leave. Stay here for a couple of minutes just in case some people have any queries. But you're free to leave. Okay, Akshat, Pratik, Arya Chandan Reddy. Thank you for